Hi there and welcome to this video for senior physics on electrostatics and electricity. In this video we're going to explore Millikan's experiment and look how the charge of an electron was established. Now Robert Millikan was basically an American scientist. He was born in 1868 and died in 1953. He gained the Nobel Prize for his research on determining the charge of an electron in 1923. Now basically what he did was he used a machine which used electric fields to determine the charge of an electron, as well as determining the mass of an electron. This charge became known as the elementary charge, basically because the single unit that we use in electricity is the electron. Now there are two types of charges. There's the positive charge and then there's the negative charge. The negative charge being the electron and the positive charge being the positron. Now the charge in each case is 1.6 times 10 to the negative 19 coulombs, and this is what was established by Robert Millikan. So this is the oil drop apparatus that he used. It consisted of an atomizer at the top which contained oil. Now this oil was sprayed through rather like you would spray perfume. It used a rubber bulb and then the oil was sprayed in a fine mist into the machine. There were also X-rays, and X-rays had the job of putting on or removing electrons. And then there was a microscope which allowed him to observe an individual drop. Now attached to this, he also had a power pack, which basically put a charge on two plates, two parallel plates. There was one at the top and one at the bottom. So how did this work? Well, basically you can see at the top here, we've got the atomizer, and it's spraying the particles into the chamber. Now there's a small hole in the top plate. Now this top plate was positively charged, and these electrons then fell through the top plate. At that point, X-rays were bombarded into these oil droplets, and as a result, either put on or removed electrons. Now, by placing a charge across the two plates using the battery, which you can see on the left-hand side, Millikan was able to change the charge that was occurring on the plates. Now, the top plate would be positively charged and the bottom plate would be negatively charged. If the oil droplets had addition of electrons onto their surface, then they would be attracted upwards towards the positive plate. However, if it was the other way around, they would drop to the bottom. Now, by taking those negative charges and applying the positive charge to the top plate by putting electrons on the bottom plate, what Millikan was able to do was move the oil drop upwards. Now, the oil drop would normally fall due to gravity. So basically what we got, as you can see on the left-hand side, if we've got added electrons onto the oil drop, making it negatively charged, the first thing that would happen is that they would drop due to gravity. So the mass of the electron or the mass of the oil drop would fall due to the effect of gravity, where m is mass and g is gravitational acceleration. Now, using the microscope, he was able to alter or vary the positive charge on the top plate, which caused attraction from the negative electron to the positive plate at the top. Now he was able to get it stationary, and when he got it stationary, the result was that the electric field pulling it upwards equaled the weight force acting downwards. So as a result, we got these two equations where we got Q times E, which is the electric field strength acting upwards, and M times G acting downwards. So putting these two forces together, we got Q times E equals M times G. Now he already knew the mass of the electron and he could work out the electric field strength by looking at the voltage that he had across the two plates. From this, by simple rearrangement, he was able to determine the charge Q. Q equals M times G over E. So what did he find? Well, the key thing is he didn't actually find Q. What he found was a difference in values depending on the types of voltages. And he got a set of equations or a set of results that look like this. Now basically what you can see is on the left hand side we've got voltage, in the middle we've got the charge, and then we've got the change in charge all the way through. So he was able to work out the change in charge based on as we move from one type of voltage to another. And what he noticed is the change in charge went up by a certain number. And that, excuse me, that certain number was based on the electrons that were added to the actual oil drop. Now you can see here in pink, we've got negative 1.6 times 10 to the negative 19. Well, that basically related to one electron. Now, for 2 electrons, we got 4.806 times 10 to the negative 19. Now, if you multiply 1.6 times 10 to the negative 19 by 2, you will get 4.8. And as a result, they were going up in increments of 1.6 times 10 to the negative 19. 3 electrons gave us 3.2, and 4 electrons gave us 6.4. Now, the difference between positive and negative is solely due to whether the electrons have been removed or added to the oil drop. Obviously, if they've been added to the oil drop, they'll be negatively charged, and if they're taken away from the oil drop, they'll be positively charged. But the key thing to understand is that the difference between the charges was of a quantized amount, a certain amount. It's never higher or lower. It's always the same difference. And this is because an electron has the same charge. It's never higher or lower or bits of a charge. It's always quantized. It's always the same amount. So from this, he deduced that the charge present on an electron was 1.6 times 10 to the negative 19 coulombs. Okay, well, I hope that you found that useful. I've put on this post a YouTube clip which gives a further explanation. You can see with some nice animation how the actual charge was established. Okay, well, thank you for joining me, and I look forward to you joining me again. Bye for now.